Hi there and welcome to part 11 of our Learn to Program with C tutorial series. In this episode we're going to look at C strings or character arrays. So they are just arrays of characters, and we looked at arrays in the past two episodes, but there's some nuances and some kind of convenience elements of the language which allow you to deal with strings. Not a lot, unfortunately, but they are there. And also the way you declare them. There's different ways to declare them that has different implications. So let's just get on and show some examples. So if you wanted to declare a string, then one way of doing it is like this. So char a, so the same way we would declare any kind of unsized array. And of course, when we declare an array without specifying a size, we need to specify the data. Now with strings, you can do something special. We can do this. So we use the double quotes to put the string inside, and most people are kind of familiar with this double quoting of strings. And what this does something special. So strings in C are null terminated. Let me show you what that means by drawing an alternative declaration for this string. Right, I need quite a lot of space for this, so let's start over here. So char a equals, and then we can explicitly declare this string. So we'll single quote each of the characters, because that's how you refer to characters. H, E, L, L, O, so that's a single quote, and then we put the null terminating byte in explicitly. So we do that with backslash 0. That's a kind of obvious way to do it. You could also just put the number 0 in there if you wanted. And so this then is an array, a character array that has the following characters in it. It's got 5 characters for our main part of our string, and then it's got a null terminating character. That is just the byte 0. So the binary sequence 0, 0, 0, 0, 0, 0, 0, 0. And that's how strings are terminated in C. So if you pass any of these strings into a function to manipulate them, so to print out a string, if we did something like printf, and then we use the format modifier %s, and then we'll do a new line, we passed a into it, printf would expect the string A to have a null terminating byte, and that's when it would stop processing and stop printing out that string. So that's what the null terminating byte's for. But you don't have to explicitly declare a character array like this, because that would take, it'd be a hell of a ball ache, wouldn't it, to have to do that every time. Whereas just putting it in quotes like that is much easier. And it will put that null terminating byte in for you. Now, what we can also do is we could do char a 6 and explicitly provide the size, and then write hello, and that will do exactly the same thing. And it will put a null terminating byte at the end. If we did char a 5 hello, we will not have a null terminating byte, because this only has space for 5 things. So that's just a little quirk. But it's very rare that you would actually explicitly provide the size and then make an assignment like that. Like, why would you bother providing the size? You may as well just omit the size and allow C to append that null terminating byte and make sure there's enough memory there. So that's the first way that you could declare a string. There is another way, and a manner which is different. So what you can do is do this. So we declare a character pointer and then we say hello. Let's call this B because it's different. It's a different way. Now, this will do the same thing, but there is a subtle difference here which is really important. What happens here is this string will be put in part of the memory of the computer when the program is loaded into memory that is usually read-only. And this is done for various efficiency reasons and so on. So what that means is you can't change this array if you do it like this. It's as if this was a kind of constant. It's read-only. And if you try and do something like B0 equals, you wanted to change it from hello to bellow. So when we declare it like this, we can do things like A0 equals B, and that will be changed to bellow, because this is like a local variable declaration. So it really is a shorthand for what we wrote earlier when we can explicitly set each of the characters. Whereas this is different. This creates hello in read-only memory and then creates a pointer to it. So when we try and access, change it, because it's read-only, that will cause the program to crash. Let's look at some examples of that now, just to get that clear. So the first string then we're going to declare, we'll call it A, and we're going to declare it like this. Hello. And we can just print that out using a function called PutS, which stands for PutString. This is a quicker way to do the same as this. So we could do printf and then use the s modifier as well. So let's just do both of those. There we go. And we just print out that string twice. So we do either of those. PutString just takes the string and prints it. So it's slightly more efficient. Well, it's quite a lot more efficient because it doesn't need to process all of these format modifiers. So that's the first way that we can declare a string. Now, let's see what happens if we do this as well. What we're going to do is call that B. And we're going to just print off both of these. And we're going to actually surround the string with quotes. So we're going to print out A and then we're going to print out B. You can see that's fine. Everything works fine. So what happens if we do this? So we've not actually provided enough memory for the null terminating byte. What will happen here? So that needs to be C. Print out C. So it compiles fine. That's curious. And what's actually happened here? So these are allocated on what's called the stack frame for this function main. And this third one, where it's allocated in memory, so the stack grows down from higher memory addresses to lower memory addresses. Don't worry about this, you don't need to understand this, but I'm just explaining it in case you're interested. And this is in this case immediately, C is immediately before B in the memory address. So it's as if you've got C and then right after it you've got B. And then when printf is processing this last string, because there wasn't space to put the null terminating character, there is no null terminating character. So it goes all the way through hello and it just goes on to the next memory address, which happens to be B here, goes through hello again and then reaches the null terminating character at the end and then stops. That's why we print hello, hello. I just thought I'd keep that one in there because it's quite an interesting one. Another one, let's just do this explicitly. So we'll have to put in each character explicitly. It's a bit dull, but it's worth having a look at. and it's null terminated. So we can null terminate it like that. So \0 will be a null termination. That would also be a null terminating byte. \0 is conventional, and maybe on some other compiler, on some wild architecture, perhaps it's not really null terminated. Maybe they've recompiled everything, and this null terminating character is not 0, but sort of a byte 0. Probably not, but anyway, that's perhaps a better way to do it. So now we've got D in there, and print out D. Yep. Forgot the brackets there. Oh, we really need to print these out so we can see. So if we put in A, B, C, D. And there we go. So hello is here again. And you can see that these are all equivalent, functionally equivalent things. Well, A, B, and D are, that they all have the null terminating byte and behave as you expect them to, whereas C is not behaving as you expect because we haven't got enough space. Remember, in these, it allocates enough space according to what data you provide it. Let's do another one where we know there's no null terminating byte. Compile that. And again, for E, we've again got hello, hello, because what we're doing here again is when printf is past E, it's looking for this null terminating byte. It doesn't see it at the end here, so it goes to wherever in memory is next, and that happens to be D because of the way memory is declared and the way that local variables are put in on the stack. And if I were to change this to a B, it would make it very clear. So hello bello, it's definitely D that we're printing out there. And then we stop at this null terminating byte. So hopefully that's made it very clear that a string terminates in a null terminating byte. And there's lots of different ways that you can declare it. So let's create another program called hello string pointer, I think. Right. Now what we're going to do is we're going to declare a string like this. So this is a character pointer. And we're going to have B as hello like this. And we'll print these out. And we'll just compile that, and then we'll run that. Right, everything is good so far. So A, we can still print out, and we can still use as a string like that. And a lot of the time, you probably don't want to change the string. So you're just going to leave it as hello. So actually it's fine to allocate it like that if you want. And in a way, if you do declare it like that, you're kind of telling the programmer this is constant. But the programmer might forget, or he might receive a pointer to this string inside a function. Maybe he's looking at a certain point of the code where he only looking at one function in a really complicated program, and he sees this string pointer come in and doesn't necessarily know that that's read-only. Let's have a look what happens if we try and change the characters in the strings, just to explicitly show you the distinction between the two. So if we try and adjust B, we'll start with that first, and we'll change that to B, and we'll print it out again. Oops, sorry, I just ran the wrong program. So, yep, we've changed B to bellow. Let's now change A to C. So we want to print cello and try and print that out. we get this segmentation fault, hello string pointer. This is because this is read-only memory and we cannot access it, and that crashes the program. Let me explain what happens. So whenever, this is called a string literal. Now, a string literal is only copied into an array when it's a character array. Wherever else a string literal is used, that will be allocated in some static memory by the compiler, and then the pointer will be copied. To show you this, the difference between this explicitly, let's have a look at this. If we were to declare some memory for a character array somewhere, and then we did this, what do you think will happen? Well, what will happen is the memory that we allocated is just essentially going to end up unused, because when we do this assignment, because we're not assigning it to a character array, so we're assigning a string literal to a pointer, this string literal will be allocated in the static memory, and then the pointer to hello will be copied into B, and B will no longer point to the memory we allocated. So that really shows you the difference. Whenever a string literal is used anywhere other than in a character array declaration, it will be allocated in static memory, and a pointer to it will be passed back as the thing that's being assigned. And if we do that, and we do this, we will get a segmentation fault, because we're trying to write to read-only memory. Let's take a quick look at that as an example. So if we declare a memory, a variable called A, and allocate 6 bytes to it, if we want to be clearer, we might want to say size of char, just so that at a glance someone can see that you're allocating chars, but they're the same thing. Then if we do this, when we print this out, we're actually going to end up with the expected output. Prints out hello. And you might assume then that actually this area of memory that we allocated now contains hello, but it doesn't. Because we've used a string literal outside of an array declaration, the compiler will create space for hello in static memory, and then it will assign that pointer to that memory address to A. So A will no longer contain the memory that we allocated, and to show that, what we can do is we can print out the address of A. So let's just say, we'll call that ampersand A, and we can use the P modifier, which prints out a pointer, and we'll just print out A, and we'll print it out before and after our assignment, so you can see what happens. And there you go. So that was the memory address of A before. So after we allocated it, the memory we got, and then after we've made this assignment, A now points to a different area of memory because this is in this static area of memory. So I hope that's made it explicitly clear, and just to show you, if we try and change A now to a C, what we'll get is a segmentation fault because of that, because this is now a read-only part of memory. If we did want to achieve the functionality that we were just looking at, we could do something like include string.h to get a load of string manipulation functions, which is what we're going to look at next. And we could use something like the function string n-dupe, or string n-copy, sorry, which is going to copy into A, the memory address of A, the string hello, and we're saying copy at most 5 characters. So this is a bounded copy function, because remember that strings were null terminated, and so
it's always best to bound the number of characters you're going to copy with reference to the size of your array. Now the size of our array was 6, and we're saying copy a maximum of 5. String n copy is not guaranteed to null terminate A. It would in the case above, but what we can then do is explicitly null terminate the array, and then we print out the array. So we'll just use PutString there. And let's have a look. So there you go. So that is a way you could do it. And if you just want to check, if you want evidence that the addresses haven't changed, just let me point them out, print them out. You know, this string n copy is not changing the memory addresses because it's copying hello into A, and it's copying it. But what will happen here, essentially, this is going to be allocated in the static memory, and a pointer is going to be passed to string n copy, which expects a pointer for its second argument, and it will just copy that string into there.
You might be wondering, well, what is the type of this? Well, we know that this is a pointer, a character pointer. What is this? Well, this is actually an array type, a character array. In some senses, pointers and arrays are equivalent, in the sense that if you pass an array type to a function that expects a pointer type, then the array type will decay, it's called, decay to a pointer type. So what that means is that you can pass these, a character array, you can pass it into a function that expects a character pointer. And that's true of all arrays actually, which is a very useful function of arrays, because in that sense you can treat them the same. They're not the same because the array type is a name given to this character array, whereas B is a pointer to that character array. So this is a memory address, whereas this is just a name for that array. That doesn't really matter. What really matters is that you can pass that into a function that expects a pointer. So now we're going to look at string functions. That is the functions provided in string.h, and in general just talk about other functions that would take strings. So most of them will take the type char pointer. That will be the type of the argument that most of the functions accept. So what you might want to do, although there is an implicit conversion between a char array type like that and a char pointer, when you pass something like that into a function, what you might want to do is explicitly create a pointer to that, so it's absolutely clear what you're dealing with. So we might have AP, and we can say, we use this address operator that we looked at in the arrays, and we can take the address of A. Now that will actually take the address of the first element of A, which is A. Then we can pass that around. Now there's an advantage to doing this and using a pointer in that we can pass pointers not necessarily to the start of a string, which this would do, but into the middle of the string. So let's start with another string, A, and it's hello world. We can create our character pointer, AP, and that can point to the address of A. And by the way, you could write, and this is equivalent, you could write the address of A 0. So for the 0th element, that's equivalent. That will point to the start of it. What we could do is say, imagine this is our world pointer, for want of a better expression. And we know that world occurs at position 0, 1, 2, 3, 4, 5, 6, we could then say address at element 6. And that will then be a valid character pointer. It will just start here instead. And then when we pass that into any function that expects a null terminated string, it will simply act as if that was the beginning of the string, and it will process it until it gets to its null terminating byte. So I mean, if we had, then you can see how this would obviously work. If we took the address of the first one, we're here at position 0. So this is our ampersand A, or our ampersand A 0. Otherwise we're 0, 1, 2, 3, 4, 5, 6. This is position 6. So this is A6. Like if we'd explicitly done A equals like that, then it would kind of make sense, right? But our null terminating, sorry, I meant to put a null terminating there. So we've got our 0 here. Because our null termination is there, if we pass in this address, whatever function is processing it is just going to go along until the null termination. So in that way you can pass pointers into strings. And I know we haven't covered pointers yet, but I think with this kind of introduction, probably you can kind of start to understand some of this stuff before we formally introduce pointers. I think you're already starting to get it by looking at things like this, that it's just the address of into some kind of data structure, in this case a character array, and it could either be at the start or halfway through. And that's really useful to be able to do that. Let's have a look at an example of that.
Looking at that example on the board, if we have a character array that says hello world, and we can then create a pointer to it that starts at, and we'll be explicit here and say it starts at A0, but just to show you that it's the same, we'll have a second one that's taking the address of just A, and then we can have another one, actually let's say A pointer, B pointer and C pointer, that takes the address at character 6, and then let's just print those out again. So we're going to have AP, B and C, and take a look at the result of that. Yeah. Yeah, so with this, we need to cast these to char pointers. These are only warnings, you don't have to do this, but it's regarded as better to do this. Now we run string functions, and there you go. So AP and BP both point to the start of this string, and when we pass them in as string pointers or character pointers, we get the whole string printed out. When we took the address of the 6th element, this W, and we create a new pointer from that and print that out, then we just get the end of it. And just to kind of speak about this, the null terminating character a bit more, if we, for example, replace this space with a null, then all of our strings would terminate there. So let's just do that. So if we said that in A, in fact we could use any of these are all the same. AP is also an address index to the start of A, so we could address it like that, but we'll just use A then, just to kind of address the original variable, even though they're all equivalent. And if we say that that equals the null terminating character, and then we'll print these out again and see what happens. And so we compile it. So they're the first three. So here are the third three. Now the first two are just hello, because we've made that the null terminating character, so they stop there. But we haven't changed the rest of it, so there's still this and then a null terminating character in this array. So when we print out CP, which starts at character W, we still print out world. So hopefully that illustrates how we can get the address of an index into an array, and then it just becomes essentially another string. But it's not a copy, it's actually all acting on the same array.
I hope that was clear. A lot of functions that we're going to call from some of the standard libraries will be manipulating character arrays like this. They'll be taking indexes into arrays. For example, there's a function string char, strchr, which will look for the first occurrence of a particular character, and it will return the index into the character array. Well, then what you can do with that then, if you want to then look for the next occurrence of that character, you can call the same function again, but you take the address of where you found the last character, which will then find the next one. And you'll see that a lot in those functions, and there's quite a lot of essentially pointer arithmetic and pointer manipulation in calling this C string functions. That's probably for that reason that people don't like string manipulation in C and say, oh well, look how easy JavaScript is or whatever, where we can just concatenate strings easily. And it's true, they are easier for sure, but these aren't difficult once you get the hang of it. So that's what we'll do next. I'll show that example of finding every index of a particular character in a string, so you can see that, and then I think we're probably done.
Let's go ahead and do this. So we want to use the string char function to search for characters. If we do man string, we can see that it's in string.h. So I already knew where it was, right? And there it is, string char, that's the function. So we need to include string.h. Now, if we do man string char, we can see what the function looks like. The string char function locates the first occurrence of C converted to a character. So this is the thing we're searching for, and it's an int, but it's converted to a character in the string pointed to by S. So the string we pass in. The terminating null character is considered part of the string, therefore C is null, the function is located terminating null. Right, now here's the important part. The functions string char and string rchar return a pointer to the located character, or null, if the character does not appear. So what we're going to do is we're going to keep calling string char and we're going to move further and further into the string as we call it, and we're going to print out every occurrence of a particular character within a string. So let's do that. So we need to start with a character string to search within, and we're going to call that Humpty Dumpty sat on a wall. And the character we're looking for, let's call that search char, and let that be U, and we'll say replace char is O. So we're going to change it to Humpty Dumpty because we're completely bonkers, right? And we need to call this function, and we want to keep calling it until we run out of characters. So we want to call it, and then we'll find this character. We want to call it again, find this character, and then we'll run out. Now, the function returns a pointer into this string. And as we were explaining before, that is essentially like a new string that starts at that point. It shares the same memory, but we can treat it and pass it into functions. So what we'll do is we're going to call string char to find the first character, print out its location, change it. Then we're going to call it again, but we're going to call it with the new pointer that we just had. So it's like we're calling it then on this string. So we're then going to get to here. And then we're going to call it again, and it will be like that we're calling it on this string. But we're going to change U before we call it again. So let's do that. So we're going to do that repeatedly, and we're going to do it in a while loop. Now, we need some space to store the pointer. So to begin with, our pointer is going to be the address of A. And just to be clear, we'll say then the address of A0. So the very start of the string. So we're starting here. And we're going to then, equals. And by the way, we're going to have to cast that to a character pointer. Otherwise, we'll get a warning from Clang saying, oh, this is a character pointer, and this is a a character array, it will actually say it's a character pointer, but that has a particular length, and it will say the length of that. So we have to do that cast there. But the warning is quite self-explanatory if you see it, and you'll know what to do. Now, so we'll say that AP equals string char, and we said we call it with the string that we want to examine. And in this case, the string we want to examine is going to be AP. We're going to start here. Okay? And we're looking for our search char. Now, we're doing an assignment here as well as comparing something in the while loop. And you'll see this a lot in C. So it's worth getting used to. And what we could do is explicitly make the comparison while the return result of this is not null. Because we saw that it said it returns null when it no longer finds the character. Right, so when we first call this then, we're going to find this u. If we didn't find any u at all, this would return null. We'd get a null here. This would be evaluated as false because null would equal null, and we'd break out the while loop and we would do nothing, which is what we want. Otherwise, we find this u, AP is now a pointer to here. So it's like we have this string, essentially. So then what we want to do is, we will say that AP0, because we're here, we've just essentially got a string that looks like that. AP0 equals O. Oh, replace char. Now, and maybe we'll just do that for now. And I'll tell you what, we'll print out the string. So before, we've got our string, Humpty Dumpty sat on the wall, and we'll have A there, and we're going to have after as well. We're going to print it out after and see how it's changed. So after we've done that the first time, we've then said that we've got this pointer here, and we've got this string essentially. Now we're replacing this character with a O, which is our replacement character, and then we go around the loop again. But now AP is pointing here. So we're passing that into string char. So we now search from this point onwards looking for a U. And we've just changed that. So if we didn't change it, we'd immediately find a U. So if we weren't changing it, we'd have to start here. But because we've changed that to an O, we'll go on to here. That is then returned from string char, assigned to AP. So AP now contains the pointer, which is then compared against null. It's not null. So we go in here and we make the next replacement. And we do that after that time. The new string is now this. We pass that into string char, and we look for U, but there's no more U's, and so it returns null. So then this evaluates to null, and we break out the while loop, and we're going to print after. So that is it. So let's have a look. So before there we go. So before, Humpty Dumpty sat on a wall, after Humpty Dumpty sat on a wall. So you see that we've done that, we've replaced the characters. And I guess now you can probably see why it's a little bit, C is not really renowned for string manipulation, because it doesn't have built-in things where you can easily do things. But you could easily just write a function called replace character, which takes a string and does the replacement. And once you've done that, that's it. And you will get used to this, trust me. I know this might look a little bit complicated, but you will get used to this. And the next session is going to be about pointers. So we're going to cover pointers in a bit more depth. But the main thing is really familiarity. You've just got to practice programming these things.
You've seen that from a string or character array, you can take the index of it and then turn that into a pointer, essentially another string that just begins within that string. And you've seen how to then use that with a function out of string.h to find every occurrence of a character and then replace that. There's a lot of functions in string.h and there's string manipulation functions elsewhere. We're not going to go through all of them because there's a lot of them and it probably wouldn't be particularly useful. Typically with programming, what will happen is, I mean, you can go memorize all these functions, but what most people do is just when they need to do something, they then find the functions and look for the functions. It's probably worth reading the man pages just to be familiar. And you'll gradually become familiar with these and be able to use more complicated functions and do more complicated things. But I think you're in a good position to do that now. So as a final thing, this is going to be an exercise. I wonder if you can work out, and I'm going to give you the answer straight away, because instead of putting it at the start of the next episode, that disrupts the next episode a little bit. I'm just going to give you the answer. So you pause it here and go and do the exercise and then have a look. So the exercise is, can you declare an array of strings? So, at index 0 of the array, there'll be a string. At index 1, there'll be another string. And then print all those strings out. Can you do that? Try and do that now. Pause it and then come back. Okay, here we go. Here's the answer.
So this is how you do it. So we're going to create a pointer to a string array. So essentially this is a pointer to a character array. So it's a pointer to a character array. So this would be a character array. And because we put that there, it's a pointer to a character array. We need to specify its size explicitly in this case. And then we can actually put strings in here. So hello, my name is Ashley. New line. And that's our string array declared. So what this is a pointer to a string array. So at index 0 there's a string array, and when we take a string array of say index 1, then we get here. Index 2 is here and 3. So now what we can do, we just go through them and we'll just do this explicitly. String, we'll just print D. And then the string itself. So we can say string array I. And let's have a look at that. What are these errors? String array, line 423, error expected. Line 423, error expected, semicolon at end of declaration. What? Oh yeah. String array equals, and then our braces. Right. We'll just recompile it because the other errors might be caused by that. And there's two warnings. Format specifies type int, but the argument has type char pointer. True. We've got an int format specifier there, and we'll pass it. Our first argument is actually a string. Forgot to pass in the index to print that out as well. What else? Yeah, more conversions and data arguments. We've just seen that one. So to compile it again, we're cool. Let's run it, and there you go. So these were the 5 strings. Hello, my name is Ashley, and this one obviously included a new line, so that's why this is on a new line. And we could of course print all those out as well if we wanted, if we just change this around a bit. So instead of printing a new line at the end of it, we just print each string. We get the string we want. Now this is useful to be able to have something like a string array, because like you might have a bunch of error messages and you want to write them all into some error message array that you can pass around or something like that, and this is an easy way to do it.
Did you get the answer right? Well, it doesn't matter if you didn't, you're still learning. But that's all we're going to say about strings, and I hope that was useful. Next episode, we're going to look at pointers and try and cover pointer arithmetic and pointers in more detail. And then we'll start to look at some perhaps more useful things. But these are the stuff we're looking at the moment is still kind of the fundamentals of the language. And in a way, it's kind of the basics of the language. So we need to get this stuff done and well understood. Anyway, hope that was useful and thanks for watching.